computer. All right. Greetings, Earth and Space Explorers. Welcome to Doc Waller's Earth and Space Report for Friday, January 24, 2025, the first of these monthly gatherings for this year. I'm your host, Bill Waller, an astronomer, science educator, and communicator coming to you on a cold and clear evening here in my hometown of Rockport, Massachusetts. These Earth and Space reports are intended to engage and inform people like you who are curious about Earth as a planet, who care about our life-sustaining biosphere, and who wonder about the greater cosmos and all that it has fostered throughout space and time. Video recordings of these reports are archived on the Earth and Space Reports YouTube channel. They are also in regular rotation on the 1623 Studios Community Access Cable Television
I don't
channel.
see any controls.
If you could mute those of you, thank you. I am grateful for the continuing interest and support shown by Rockport educators and students, Cape Ann cultural colleagues, cohorts of the Gloucester Area Astronomy Club, myriad Earth and space scientists, educators, and communicators, far-flung friends, family, and other curious folk. Thank you for your active participation and encouragements. This evening, we will explore one of the major environmental issues of our own making, namely the plastic waste stream that permeates our waters, air, and even food. Our guide is Hayden Spencer of Seaside Sustainability. Hayden is a senior student at Manchester Essex Regional High School who will be attending Wake Forest University this fall. Hayden has maintained a keen interest in the environment from a young age and hopes to pursue a degree and career with an eye towards sustainability. Hayden became interested in the plastics industry after seeing the devastation plastic was causing along his local seashore. He was inspired to aid in the cleanup effort after he witnessed several animals wash up on a local beach that were trapped in plastic waste. His passion for the environment was the driving factor behind him joining Seaside Sustainability. He has since become an integral team member, helping Seaside Sustainability with its cleanup efforts, environmental documentation, and informative presentations on the myriad dangers of plastic pollution. But before Hayden starts, I'd like to introduce Eric Majors, who directs the Seaside Sustainability Project. Eric, unmute.
Unmute. Thank you.
All right.
Hello, Bill. Thank you, Bill, for inviting us. So Seaside Sustainability, we do a whole bunch of things in the environment. I just shared our chat, our website in the chat, seasidesustainability.org. A little long, but we do a whole bunch of things. But this one in our plastics falls very squarely in our marine science and education department and our program. And I'm going to actually pass it over to Bridget. So thank you all, Bill. It's been wonderful to have you invite us here, and I really appreciate it. So Bridget is going to do a little bit more explanation about what we do at our marine science, and then Hayden's going to take it away.
Sure. Hi, everyone. I'm Bridget O'Connell. I am the Marine Science and Technology Fellow at Seaside Sustainability. About me personally, I graduated this year from Massachusetts Maritime Academy in Cape Cod, Massachusetts, but I've been working at Seaside Sustainability for a little bit over 2 years now. I started out as an intern and moved my way up to a fellow, and for the past 6 months, I've been working with Hayden, mentoring him on this plastics presentation he's about to show you. The Marine Science and Technology Department, we have 3 sub-teams: Marine Science and Education, we have Blue Technology, and we also have grants and sponsorships. Marine Science and Education, that team, we create educational materials for online schools, educating others about plastics, marine debris. We also have in-person internships as well that we also will be having this summer that Eric will be in charge of. Blue Technology, that is the running of technological devices that go into the water and clean up plastic debris. Hayden will be talking about more of that later. We have programs such as the Clean Coast Coalition, and we're going to be hopefully forming a new BBOT program this upcoming spring and summer. We also have a grants and sponsorships team that helps us with all of these initiatives, finding sponsors to help us improve our programs. So that's just kind of an overview of what we do, what our team does, and I make sure all of this runs smoothly on a daily basis. I'll pass it over to you, Bill.
All right, and I'm just going to hand the ball over to Hayden. Let's get going. The Zoom platform is all yours.
Okay, thank you, William. And hello, everyone. That was a good introduction. Everyone heard that. I'm going to share my screen so I can get the 1 second. Okay, here we go.
Looks
Everyone
good.
can see that. Okay, so plastics. You all heard my introduction. I have a little table of contents here. The numbers coordinate to slide numbers, so if you want to, click through on your own time, I'll be happy to send this presentation to anyone. But yeah, so we'll get right into it with plastics today. So, plastics today. I think important to always start with the general question of what are plastics? And that's a hard one to answer, but mainly it takes many shapes, but it's a polymer. And what a polymer is, it's a chemical bond that is very stable, hence why it persists in the environment for so long, as most of you know. Creating synthetic plastic, it's a really complex process that involves extracting natural gas and from the ground and using chemical processes to convert it into the familiar materials that we know. But we are right now in the middle of a century of plastic, or the century of plastic, sorry. So what does that mean? Well, this video
Today, plastics are everywhere. All of this plastic originated from one small object that isn't even made of plastic. For centuries, billiard balls were made of ivory from elephant tusks. But when excessive hunting caused elephant populations to decline in the 19th century, billiard balls makers began to look for alternatives, offering huge rewards. So, in 1863, an American named John Wesley Hyatt took up the challenge. Over the next 5 years, he invented a new material called celluloid, made from cellulose, a compound found in wood and straw. Hyatt soon discovered celluloid couldn't solve the billiard ball problem. The material wasn't heavy enough and didn't bounce quite right, but it could be tinted and patterned to mimic more expensive materials like coral, tortoiseshell, amber, and mother of pearl. He had created what became known as the first plastic. The word plastic can describe any material made of polymers, which are just large molecules consisting of the same repeating subunit. This includes all human-made plastics, as well as many of the materials found in living things. But in general, when people refer to plastics, they're referring to synthetic materials. The unifying feature of these is that they start out soft and malleable and can be molded into a particular shape. Despite taking the prize as the first official plastic, celluloid was highly flammable, which made production risky. So inventors began to hunt for alternatives. In 1907, a chemist combined phenol, a waste product of coal tar, and formaldehyde, creating a hardy new polymer called Bakelite. Bakelite was much less flammable than celluloid, and the raw materials used to make it were more readily available. Bakelite was only the beginning. In the 1920s, researchers first commercially developed polystyrene, a spongy plastic used in insulation. Soon after came polyvinyl chloride, or vinyl, which was flexible yet hardy. Acrylics created transparent, shatterproof panels that mimicked glass. And in the 1930s, nylon took center stage, a polymer designed to mimic silk but with many times its strength. Starting in 1933, polyethylene became one of the most versatile plastics, still used today to make everything from grocery bags to shampoo bottles to bulletproof vests. New manufacturing technologies accompanied this explosion of materials. The invention of a technique called injection molding made it possible to insert melted plastics into molds of any shape, where they would rapidly harden. This created possibilities for products in new varieties and shapes, and a way to inexpensively and rapidly produce plastics at scale. Scientists hoped this economical new material would make items that once had been unaffordable accessible to more people. Instead, plastics were pushed into service in World War II. During the war, plastic production in the United States quadrupled. Soldiers wore new plastic helmet liners and water-resistant vinyl raincoats. Pilots sat in cockpits made of plexiglass, a shatterproof plastic, and relied on parachutes made of resilient nylon. Afterwards, plastic manufacturing companies that had sprung up during wartime turned their attention to consumer products. Plastics began to replace other materials like wood, glass, and fabric in furniture, clothing, shoes, televisions, and radios. Versatile plastics opened up possibilities for packaging, mainly designed to keep food and other products fresh for longer. Suddenly, there were plastic garbage bags, stretchy plastic wrap, squeezable plastic bottles, takeaway cartons, and plastic containers for fruit, vegetables, and meat. Within just a few decades, this multifaceted material ushered in what became known as the plastics century. While the plastics century brought convenience and cost-effectiveness, it also created staggering environmental problems. Many plastics are made of non-renewable resources, and plastic packaging was designed to be single-use, but some plastics take centuries to decompose, creating a huge buildup of waste.
Yeah. So that was a little backstory to the whole plastics issue, how we got to where we are today. So furthering the century of plastic discussion, China today is the world's leading producer and exporter of plastic. That could potentially because for a number of reasons, but mainly because it has loose regulation on labor laws and workplace safety standards. So these factories can output cheap, poorly constructed items at very high rates and low prices. We all know the made in China tag that can be found on a lot of things, mainly plastic items. What I like to have people do is just to look around them, and on your desk in front of you, you might be able to find 15, 20 items made of plastic. So it really calls attention to how it's everywhere. And notable companies today that utilize the most plastic, Dasani, Smart Water, soda companies, hygiene products like Axe and Dove, makeup products, toothbrushes, utensils, all this stuff all uses plastic. And here are some things that you might not have known use plastic. It's things that look like cardboard, such as these cups, are actually plastic. Tea bags, sponges, receipts. You might think these are paper products, but actually plastic. Even stuff like you might overlook plastic, like this glass and wood, also has a little plastic rim there. I already touched on the makeup products, but these are actually produced with synthetic plastic. So it's really all around us, and it's hard to call attention to that. But here we have a little discussion on what the issue is exactly, why plastics are so bad. It's mainly because they're cheap and easy to use, and they have little to no infrastructure in place to prevent the littering and pollution, such as, trash cans aren't readily available all over the world or even in this country. There's not much public infrastructure in place, and they're so versatile. They can be dyed, they can be molded. Plastics are really just unique in that they can be used in every which way. And that combined with the fact there's no infrastructure means that it's going to end up in our natural ecosystems. In fact, estimates suggest that between 8 million and 11 million tons of plastic enter the ocean each year, the equivalent of dumping a garbage truck of plastic into the ocean every minute. So, that really puts into perspective how much plastic is entering our environments. Who is to blame for this plastics issue? That is a really complicated question, but most people would assume that it's big businesses, and they won't be wrong. Big businesses often will big businesses that utilize plastic manipulate customers into thinking it's their fault for polluting, and the plastic issue is entirely their fault, allowing them to continue producing plastic and make more money. This is an ad paid for by Coca-Cola and PepsiCo.
Some people have a deep, abiding respect for the natural beauty that was once this country. And some people don't. People start pollution. People can stop it.
So that's just an example of an ad paid for by these big plastic companies, and it's really putting the blame on, the consumer. The person throwing the plastic trash out the window was a consumer, and they're basically saying, it's your fault that the Indian land is being polluted. It's entirely on you. And that is not true at all. In fact, big businesses make you believe that it's your fault by saying that they make their plastic entirely recyclable, which is not true. Only 5 to 6% of plastics that are recycled in the United States are successfully reused, meaning that if you recycle something, odds are it's not going to be reused at all. These big plastic companies, it's cheaper to make new plastic bottles than reuse the ones that you recycle. So Nestle, for example, claims that every recycled plastic bottle that their customers recycle is guaranteed to be reused, though in 2013, 80% of their bottles were produced from virgin material, meaning only 20% of the recycled bottles were actually reused. But it's much more complicated than that when you can't really only say stop littering. We'll get into that in a couple slides, but it's not entirely on big businesses, the plastics issue. Oops. So yeah, here's just an example. You can see the top plastic producers, Coca-Cola, PepsiCo. They paid for the ad. And here's an example of annual plastic uses in 2019. So these numbers are way higher now, but you can see packaging. Main thing that these companies are using plastic for is packaging, which is in line with, these beverage companies, plastic bottles, but goes much beyond that. That's plastic's primary use. Like I said, it's not entirely on the consumer. On the producer. Wish cycling is also an issue. Basically, what wish cycling is hoping that something can be recycled and throwing it into the recycling bin just to essentially make yourself feel a little better if you're on the fence about whether something's recyclable or not. Throwing it in the recycling bin is actually not the right thing to do. It causes way more damage than if you were just to throw it away. Most people don't know this. Most people think they're doing a good thing. But when in doubt, you should definitely throw it in the trash because, these things, receipts, construction paper, clothing, pizza boxes contaminated with grease, like this stuff cannot be recycled. And when it is, it ends up contaminating a load that would otherwise be recycled and potentially reused. So throwing something that you're unsure of in the recycling bin happens millions of times every single day, and it does a lot of damage, and that is on the consumer. Here is a little diagram showing, I just thought this was interesting, how much plastic trash is used every single day. You can see, oops, let me go back to that. You can see country, 695,000 tons, just crazy numbers. And now we're going to get into some of the ways that the plastic that is thrown away is taken care of. How are we handling this excess flow of plastic and trash? Landfills are the most popular form of waste disposal. It's basically, just dumping trash in a hole there's not much to it. But something interesting is when it's done correctly, landfills are actually sustainable and potentially a superior form of waste management, though this is very rare that this ever happens, and because it's expensive, time consuming. So I just think that's interesting. Most people think landfills are the worst form, but if done correctly, they are sustainable. And this video is
The slow end of what was once the world's largest landfill. In fact, this peaceful grassy hill was built by garbage.
When the landfill was open, every borough sent their garbage here. You could see Manhattan, you could see Jersey City. You come up here when the sun's coming up or going down, it's really beautiful.
The Fresh Kills landfill was opened in 1948 and accepted trash from all of New York City until it was closed in 2001. In the late 1970s, the landfill received about 28,000 tons of trash every day. The trash piled as high as 200 feet. In the end, about 150 million tons of garbage would be laid to rest at Fresh Kills. The last mound of trash is in the process of being capped or covered through elements of design meant to keep the garbage encapsulated for years to come.
We've been capping this section 3 or 4 years, I think it's been.
Once a part of the landfill is capped, there are hardly any visible remnants of its legacy. Pipes are the only thing that litter these hillsides nowadays, working to pump leachate, or water that has seeped through garbage, to a plant for purification. The leachate needs to be purified so it can be safely released into New York's waterways. The clean water is dumped in the Arthur Kill, one of New York's waterways that doesn't have to suffer nearly the amount of pollution that it once did.
Okay, so
The slow end.
Here is how that kind of looks. You can see the liner prevents leaching, gas is collected, and eventually turned into power. That's essentially how it works. An example of this that I think is pretty cool is here is a landfill turned solar farm in Beverly, Massachusetts, next to Exit 19. You've probably driven past this every day and not really knowing what it was, but this all used to be a landfill. Now it's a solar farm. I think it's a cool example of, a full circle moment for Massachusetts on the topic of, states and their consumption and landfill usage. This just kind of shows you, who the real villains are in this scenario with these states kind of producing the most trash or putting it in landfills. We're actually doing pretty good here in Massachusetts, but across the country, you can see we're not doing great. Okay, next form of trash disposal I want to talk about is incineration, which is basically burning the plastic or trash. This is harmful for a number of reasons. Produces gases, toxins, and particulates, all of which are harmful to humans and animals alike. The really bad thing about these is that, they're big, they produce all these harmful chemicals, which means, wealthier neighborhoods aren't going to want them near them. So these are disproportionately located in areas of low income, areas of with higher African-American populations. So these don't affect everyone equally. They're very much so affecting the health of lower income households way more. And that's just another reason. I mean, beyond that, they're horrible for the environment, but landfills are not sustainable and potentially an inferior form of waste disposal. Okay. Overseas trash disposal is potentially the biggest form of worldwide, the biggest form of trash disposal. Little backstory context here. The Basel Convention is in 1989, 180 nations agreed to ban the exportation of plastic waste. The United States was not one of them. So although the United States did sign the agreement at the convention, it went on to never get passed by the Senate. So the United States is not a part of the Basel Convention. Basically, what the Basel Convention aimed to stop was the flow of trash from wealthy nations to poor nations. For these poor nations, for example, a country like Malaysia, who can't turn down the plastic waste. So, it's easy for a wealthy nation to load all this trash into these shipping containers, send it overseas, and to these countries who, when they receive it and they recognize that, the trash isn't the specified quality, or, if there's actually trash in there, sometimes they just lie. They can't send it back because it's technically illegal contraband. So their hands are really tied, and it leads to these trash mountains. And you can see here in these poor countries, and they have not the facility, they don't have the facilities in place to deal with the trash, and there's really no choice for them but to, litter the trash, create these trash mountains in these low-income neighborhoods. So it's a really bad system, and the United States continues to exploit it. So you can see here the destinations in 2018 of plastic waste exports. You can see poor waste management countries account for 78% of the destinations. So like I talked about Malaysia, you can see 19% of exported trash. So we are definitely targeting these countries that don't have the facilities in place to refuse these massive exports of trash. When I was initially doing research on this subject, I was confused as to what it looked like. So this is kind of how they're getting it to these countries. It's being loaded into these shipping containers, hundreds, thousands of them sent across the ocean. And it's really hard to regulate because, that's one ship. There are hundreds of these crossing the ocean every single day. And you open them, and out comes low quality plastic and trash. So in 2018, about 157,000 large 20-foot shipping containers, equaling about 429,000 pounds per day of U.S. plastic waste, was sent to countries that could not refuse it. So it's a really big issue, and it's disproportionately affecting developing nations. So for the next section, I want to talk about the consequences of all this plastic and all this plastic waste. Microplastics and nanoplastics. So as we know, plastics don't biodegrade. They only break down into smaller and smaller pieces. And microplastics have really taken the spotlight in recent years. They've been found everywhere: Antarctica, bottom of the ocean, even in clouds, and, obviously in human bodies. And they're typically sorted into three categories: microplastics being greater than 20 macrometers in diameter, mesoplastics are between 5 to 20 macrometers, and microplastics are less than 5 macrometers across. This video is going to explain
microplastics. Microplastics are pieces smaller than 5 millimeters. Some of them are used in cosmetics or toothpaste, but most result from floating waste that is constantly exposed to UV radiation and crumbles into smaller and smaller pieces. 51 trillion such particles float in the ocean, where they are even more easily swallowed by all kinds of marine life. This has raised concerns among scientists, especially about health risks from the chemicals that are added to plastic. BPA, for example, makes plastic bottles transparent, but there's also evidence that it interferes with our hormonal system. DEHP makes plastics more flexible, but may cause cancer. It would be pretty bad if microplastics are toxic, because they travel up the food chain. Zooplankton eat microplastic. Small fish eat zooplankton. So do oysters, crabs, and predatory fish. And they all land on our plate. Microplastics have been found in honey, in sea salt, in beer, in tap water, and in the household dust around us. 8 out of 10 babies and nearly all adults have measurable amounts of phthalates, a common plastic additive, in their bodies. And 93% of people have BP.
Okay, so that's kind of how they're formed. I forgot to mention, if you have questions at any point, just leave them in the chat, and I'll do my best to answer them at the end of the presentation. Sorry, I forgot to say that in the beginning. So this right here, this diagram shows, the life cycle of microplastic. This is how they end up in clouds, and in Antarctica, it's because, they get evaporated up. They can be transported by wind, rain, and they can end up anywhere on Earth. And, with each cycle, it's important to note that with each cycle, they become smaller and smaller as they're broken down further and further. That video just touched a little bit upon, how it enters our bodies. And you can see these are all, points of contact: ingestion, inhalation, applying it with makeup. These are all ways that it enters our bodies. And, they are everywhere. They've been found in human fetuses. Airborne particles accumulate in the lungs. They've even been found in the brain. So this video is going to talk about biomagnification, but later on in the presentation, I will go deeper into biomagnification and bioaccumulation, which are two very big
as the process
issues.
of toxins moving up the food chain in an ecosystem, and it's typically regarded as a bad thing. Now, why should you care about this complicated biological process that occurs deep in the ocean? Well, it ultimately affects you and your health. So, how is this process initiated? I'm sorry to say that it begins with you. Every plastic bottle, bag, and container has the capability to break down eventually, contrary to what most people believe. Not only is this process time-consuming, but the small plastic pieces can be ingested by tiny animals and work their way up the food chain to humans. So let's walk through an example. You head out to a nice lunch by the shore with your friends, getting takeout from a local restaurant. It's a beautiful day with a lovely sea breeze, and your excitement to get back in the water causes you to forget that you didn't throw away your plastic cups, cutlery, and containers in the recycling bin. The breeze sends the remnants of your lunch tumbling down the sand until they land in the water, initiating the first steps of biomagnification. The breakdown process starts with photodegradation, which is when UV waves from sunlight begin weakening the plastic structure, similar to how UV waves damage your skin. Think about that the next time you put on sunscreen. This process, coupled with the rough, salty conditions of the sea, transforms your plastic into microplastics, tiny little fragments of what they once were. And this is when trouble starts. The pieces settle to the sea floor or float alongside their new, same-sized friends, plankton. Plankton are a category of microscopic plants or animals that drift along in the water and are the basis of the oceanic food chain, meaning that they indirectly feed a majority of the fish, crustaceans, and marine mammals that inhabit the ocean. This enables a clam to unintentionally ingest microplastic instead of plankton as they filter feed for nutrients. The plastic has difficulty leaving the digestive system because it's a foreign object, and the concentration of microplastics in the clam increases over time as it continuously filter feeds. Eventually, a hungry sea star approaches looking for a meal. Unbeknownst to the sea star, it's ingesting not just the clam, but all the microplastic pieces that are in the clam's flesh. As the sea star continues to feast on all the clams in the area, it becomes a living dumping ground for microplastic pieces. The particles continue to move up the food chain as a king crab hunts down starfish to eat. At this point, the microplastic concentration in the crab is exponentially higher than it originally was in the clam. And unfortunately, this is the king crab that you'll be eating when you dine at a 5-star restaurant famous for its freshly caught seafood.
Good. So that is basically biomagnification right there. It's a really big way that plastic ends up in your body. Sorry, I don't know why that is happening. Here you can see a bunch of the health impacts. Irritation in the eye, skin disease, liver dysfunction, you name it. Microplastics can do it to you. Here we have a little picture of, what some of these microplastics are looking like. You can see how if you were to walk on a beach, to me, these would be indistinguishable from grains of sand even. So it's really easy for these things to sneak their way into ecosystems, and a human, not to mention a fish, would never be able to tell these things apart. They get digested and they end up in our bodies. This is a cool diagram. It took you 1 week to eat this dice. It just shows puts into perspective how much plastic you're truly eating. Granted, not all of that is absorbed in the bloodstream. Here is just a little chart showing percentage of tap water samples containing microplastics. So you can see even USA is ranking the highest, but it's not exclusive to developed nations. Everywhere around the world, no matter what your topography is, you're facing problems with microplastics. All that being said, that whole section about microplastics, the term was only first dubbed in 2004, and serious research didn't even begin till last decade. So not enough time has actually passed for these long-term impacts to be studied. So, we can make speculations. We do know microplastics are in the blood, but technically and scientifically speaking, these are only speculations as to the long-term impacts. There's not enough research right now to draw a direct contrast between microplastics and cancer, but I mean, I'm not really willing to roll those dice. So, scientifically speaking, who this really affects. So we've talked a lot about, the issues associated with plastics, but it's really affecting the people in the developing nations. They're hit the hardest because they have no education as to the dangers of inhalation of plastic. Burning plastic is massive. We'll get into that later. It's massive in these developing nations, but they have no education on the dangers of that. They have no way to handle the influx of trash. They also have there's less money. People are more willing to buy cheaper plastic products because, they're more poor. So here's a little statistic. One person dies every 30 seconds in developing countries from illnesses caused by plastic pollution and uncollected rubbish. So it's just crazy. Yeah, it's really affecting, it's hitting these places the hardest. And the fact is that the plastic issue is a power imbalance with the top 1% of the planet producing the most trash that the bottom 10% has to deal with. So it's really, it's unfair on a lot of levels. I just talked about, burning trash. And so there's no education. So these people don't understand that they're letting these little kids, play around the trash. They don't have anything else to do with it. The trash is flooding their communities. So burning it is really the only way out. And, inhalation causes cancer and whatnot. So especially on, young kids. So these people really just don't understand the damage they're doing. And it's quite unfair. Tech trash is a similar situation.
If you, as a consumer, want to do the right thing with your e-waste garbage, you won't throw it in the dumpster. You'll take it to a recycler, right? This is what the local government will tell you to do. This is what the state government will tell you to do. This is what the federal government will tell you to do. But what they don't tell you is by taking it to a recycler, that piece of e-waste has a very high probability of being exported by a ship to China or other Asian destination. And yet nobody, and we talked to recyclers, we talked to government people, we talked to industrialists, nobody had ever bothered to go look and see what that recycling in Asia really looked like.
So basically tech trash is, technology waste. It's mainly shipped over to, Asian countries overseas. And what they're doing is they're trying to extract the precious metals found in these circuit boards. Gold is a really common one. And these underpaid laborers are working hard, cruel hours with little to no protection. And they're trying to extract these precious metals. But their employers are either negligent or don't have the education to know that these circuit boards also contain toxic metals such as lead and mercury and chromium within the circuits. So, and these workers, they have no safety standards or protections. Here you can see these guys, no gloves, sitting in mounds and heaps of this stuff, making a fraction of their boss's pay to extract these precious metals. And it's really, no one even knows this is happening. It's not at all talked about. Rarely ever brought up in the plastics discussion, but it's a serious issue with these plastic circuit boards are just being exploited to make money in these Asian countries. And it's once again a power imbalance. And these guys are overworked, underpaid, and most of them develop cancer because they don't have any of the safety precautions. This guy does have gloves and glasses on, though. That being said, pollution in the water. This one kind of is less about even plastic necessarily, though plastic does pollute water, but it touches more on, the skin ointments you use. While they do feature plastic in the medicine, while it's contained in plastic capsules, it's more about, what's washing off and not getting filtered out in the reclamation process of the water. Drugs, antibiotics, antidepressants, contraceptives, on and on, have all been found in trace amounts in drinking water. Because when you take a shower, the ointments on your skin are being washed off and they're not fully filtered out. We don't have infrastructure in place to filter these things out. So, it's more of just a health hazard. Here you could see the UMA.
सन 2012 थे तो बिल्कुल कम गया ही ना है ना काम हो ना बैठा उठे कछु नहीं तादेंगे समझ जाई पे टट्टी करे वो जो कछु करती जे करते टट्टी पेशाब जो कछु करो ते जाने करो अब जे है जाके संग जो सहारे थे जो करेगा डोलिया का है और जो समझ लो जे मर गई तो फिर हमारा इल्लो खराब हुआ फिर ना है पानी सब बजाते आ वो तो नला फला कोई पी लेता है वो तो हाँ डॉक्टर ने कहे कि जो पानी चेंज कर दे और बस एक एक लीटर की बोतल आवा देगा भाई पियो इतने का दाम थोड़ा कहाँ दर है तो भाई ला के पियो 1 बीघा खेतो जाई में बिको अब जे है कि दवाई चल रही है तो चल रही है फिर तो फांसी लगावा नहीं पड़ेगा ठेला में टन्नी के नीचे कटना पड़ेगा
So that's a bit of an extreme case, whereas these people are drinking from India's most polluted river because they think it holds spiritual value or whatnot. But you can see that guy talked about some of the side effects. He's basically paralyzed from the pollution in the water. And, if we're not careful, that could be the reality of the drinking water in even developed nations. So, this water, I mean, I would drink that personally, for what it's worth. But these things can happen, and on a smaller scale, we do drink water that is contaminated and that can have really harmful side effects beyond the microplastics that we swallow. It also pollutes fisheries and impacts wildlife. Speaking of which, impacts on wildlife. How is plastic impacting these other animals and plants that we share the planet with? For starters, I mentioned that we were going to go into bioaccumulation and biomagnification. Basically, biomagnification is the concentration of toxins in an organism as a result of its ingesting other plants and animals in which the toxins are more widely dispersed. So you could see grasshopper eats plant, bird eats grasshopper, then this eagle or whatever eats a bunch of these birds. So it ends up with the most concentration of contaminants in its blood. Bioaccumulation, on the other hand, is when an organism absorbs a substance like pesticide or heavy metal faster than it can break it down or excrete it. So the substance accumulates in the organism. And this is especially important to us because, these fish are eating more toxins than they can break down and excrete. And therefore, we are eating the fish that has, very high levels of toxins, heavy metals, contaminants in its blood. Beyond that, natural obstacles can be prevented by plastic. You could see animals can mistake, obviously, the classic sea turtle eating a plastic bag. But when you put it like this, plastic bag jellyfish side by side, you can almost understand the thought process behind eating that. Natural obstacles, it's a really sad photo there. They can even mistake it for shells in homes. And this statistic here, by 2050, there will be more plastic in the ocean by weight than fish. So you could really put that in perspective. More plastic than fish is ridiculous. Impacts on the environment. Drains can be clogged by plastic. This means more and more sewage spilling into the ocean. We know what that means. Burning and creation of plastic, both release CO2, greenhouse gas, contribute to climate change. So the whole process from extracting to making plastic is dirty. You can see this doesn't look good, and it pollutes the air and the groundwater surrounding these plants where plastic is produced. You can read this little quote here that really puts into perspective how much plastic we're using every day. This video shows invisible plastic. This is plastic that even if you are cleaning up after yourself, you'd never be able to find, that's just invisible. It will make its way into an ecosystem because, we can't even see it. So, all really, really horrible stuff right there. This is a drain that's been clogged by plastic. So all these things, plastic is ending up in our environment in a number of ways, and none of them are good. This you can see every step of the way, the plastic pollution life cycle. Every step of the way, it's releasing some sort of contaminant or greenhouse gas into the environment from extraction to dumping and burning. Every step of the way is harmful to the environment, furthering the point that plastic is bad for the environment. This is an interesting video. Deep ocean trench. Not sure if it's the Mariana Trench, but That's at 10,000 meters underwater. But that's plastic. So just crazy. This stuff could end up anywhere. On a slightly more, uplifting note, innovations and innovators. Some plastic innovation, plastic roads. They're roads made of recycled plastic are cheap, light, and durable, and they can be assembled in half the time it would take to pave a road. So you can see here, this is a road in New Zealand being assembled.
This is the plastic road. The idea is to build roads using recycled plastic. It is like building roads as you would with Lego. Plastic road is modular, lightweight, quicker to install, and more durable.
You can see there, and then maggots, research is being done on maggots that can break down and consume plastic. This lady's going to explain it more in detail.
These worms are literally eating their way out of this plastic bag. But not only can they eat it, it's actually good for the planet. So if they can biodegrade plastic, could they be the answer to our planet's massive plastic problem?
Biology has found a way to some extent to deal with this.
Because the latest science on this is mind-blowing. Not only might we make plastic biodegradable, we might even one day be eating vanilla ice cream from recycled plastic and E. coli.
Yes, I mean it's chemically identical.
Yeah, so we'll get back to that in a minute. Let's start with the worms. These little creatures are waxworms. Dr. Federica Bertocchini is a molecular biologist, and she first witnessed this phenomenon when she chucked a bunch of waxworms in a plastic bag as a hobby side project, because, well, who doesn't?
I bumped into the waxworm accidentally because at that time I was a beekeeper, because they live in the beehives. They are considered plagues by beekeepers. So I started cleaning my beehive, putting the worms in a plastic bag, and within a short time I realized they were producing holes.
The plastic started to degrade almost as soon as it touched the worms' mouths.
So we thought, okay, maybe something coming out of the mouth. So we start collecting this liquid coming out. Called it saliva, but it's the liquid coming out of the mouth. So in this saliva, we found two enzymes that can reproduce the effect of the saliva, meaning oxidizing polyethylene. And it takes a few hours at room temperature in a watery solution.
And the amazing thing is that the worms can even digest the plastic, breaking it down into something useful for the worm.
The worm itself, when it eats the plastic and starts breaking it down, its guts react almost as if it was eating normal food. So that means that there's something happening with the physiology of the animal that extracts something out of this plastic biodegradation, and it just continues as if it were a normal diet.
So yeah, obviously that's at its really early stages, but it's cool stuff. It could be the future, how we handle plastic pollution.
These worms.
Mushrooms over plastic. As you all know, probably, things like leather and animal hide are really common, not only for clothing, but for bags and jewelry and whatnot. And what you might not know is that plastics in the clothing industry are used by almost every producer to make things such as synthetic fibers and fax leather. So plastic is really relevant in these two industries, the silk and fabric industry and the leather industry. So basically what this company is doing, Milo, is they're replacing these things with mushrooms. Mushrooms and spiders. So spiders can produce silk fibers that resemble, your everyday clothing, but they don't use plastic and they're good for the environment. Micro silk can be produced with less environmental impact than traditional textile manufacturing, with the potential to biodegrade at the end of its useful life. These mushrooms can replace leather, and they're almost identical and indistinguishable from, a leather from, say, a cat or an alligator skin or whatever. And they're made from mushrooms, so they can biodegrade, and they don't require the death of an animal, which is cool. Legislation is another way to tackle the plastic industry. Activation, this link shows a bunch of victories to prevent the flow of plastic. Some examples of those: December 20th of 2021, the EPA finalized federal greenhouse gas emission standards for passenger cars and light trucks. This picture is Senator Jeff Merkley speaking at a press conference to break free from plastics, as you can see there on this little podium. This is Greta Thunberg. There's like this photo, she's getting arrested, and are detained at an environmental awareness protest. She's a big supporter of plastic, or not supporter of plastic, supporter of environmental awareness and also breaking free from plastic. And she's helped win a number of legislation victories. These are some innovations that clean up plastic, such as the Bebot, which drags around a series of grates and filters trash out of sand and beaches. You know, as we saw earlier, it can get really mixed up in the grains of sand. The Pixie drone, or a waste shark, eats trash at ports and harbors, and it just floats around and collects garbage in these really concentrated areas. You know, harbors generally harbor most of the trash found in the ocean. Here is, a way you can support people and get involved is just, following creators and people who are helping the battle against plastic. This guy, Plastic Pollution Coalition. You can find your own people, but he does some good work. This is an example of people who go and clean up rivers. And some of those, it almost looked like they were putting the plastic back, though. I'm just now realizing. I can't be the only one who saw that, but definitely looked like in some of those they were putting it back. I'm sure they weren't, but another way you can get involved is cleaning up trash wherever you see it, even if it isn't yours. So you got Seaside Sustainability. This isn't that us, but where we clean up trash all over beaches and whatnot. Doing beach walks, just doing your part. And yeah, in conclusion, we only have one Earth, so let's make it count. We all need to be a little bit more environmentally conscious, and it's going to take all of us if we want to save this planet from the impending plastic crisis. So yeah, thank you everyone for listening, tuning in on Friday night. I hope you guys enjoyed the presentation. I had fun delivering it. I guess, William, I don't know how to see the chat, but are there any questions in the chat that I need to answer?
Well, first I want to thank you very much, Hayden, for enlightening us and giving us a very comprehensive and competent presentation. I invite everybody else to unmute themselves and ask their questions first before we deal with the chats.
Nice job, Hayden.
Thank you.
Yes, Hayden, thank you very much.
Enjoyed that very much. It's interesting. I thought in New York City they were using some kind of plasma burner to get rid of trash. Did they have something different going on down there that was less polluting?
In New York, I have not heard of a plasma burner. No, I will have to look into that, but that does sound interesting.
Yeah, there was something because they had so much trash down there.
Yeah,
and
right.
New Jersey's full, so they had to do something with it. But yeah, that was a great presentation. I thoroughly enjoyed it, especially some of the things at the end that gave us a little bit of maybe a direction to go in.
Hayden, could you stop sharing your screen so we can get the gallery more prominent? And then Mario, you've had your hand up.
Mario.
Yeah, a question, but more of a statement. The medically, come as a physician, the amount of microplastics is basically in every person on Earth now. It's in your lungs, it's in your tissues, and we basically have no idea what's going to happen. It can't be good for you. Mothers pass it on to their fetuses, so kids are born with plastic in their bodies now. There's some evidence that when it gets in the brain, amyloid forms around it and probably contributes to some dementia and Alzheimer's. And this is just the beginning. So there's starting to be a lot of research on it, but it's really in its infancy. So I expect lots of bad news over the next 20 years regarding this subject. Look out for it.
Yeah, right. I hope I made that clear with the fact that we really don't know. While there's no conclusive evidence of anything, that means that we have no idea the extent of the damage that this inevitably will do. So it's scary stuff. Thank you, Mario. In the chat, does anyone have, thank you, Tom, for the corrections there. Anyone have question? Doesn't look like anyone in the chat had any questions.
Yeah, they're mostly statements.
Yeah.
I could add the chat to the posting on YouTube because it's an interesting bunch of comments. But I have a question for you. Why isn't there a stronger push for glass containers coming back? I mean, for example, I like to buy fresh orange juice, not from concentrate. And right now, they're all in these hard, clear plastic containers. You really can't get it in glass. And Patty said, "Well, I use cardboard." But what's wrong with glass? We use it for peanut butter. Well, the plastic is taking over peanut butter.
I think there's two answers to that. The first being cost. I think glass definitely costs a bit more. And the second being weight. A truck full of orange juice contained in plastic bottles compared to glass, I think it'd be exponentially more expensive. And then you'd have to look at the fact that transporting that orange juice all across the country at heavier weights means using more gas, which would inevitably lead to more CO2 and global warming. So, it's not an easy topic at all. I too enjoy my orange juice from a glass bottle, and it's a tragedy that there's not really a good solution to that yet, but hopefully soon we find a way to make the switch back over.
It could be legislated, just as we have the bottle bill, and we've got the plastic bag ban.
Yeah.
So.
Other places do. I just have a couple of comments, if I could. I live in rural North Carolina. I love it here. But I have believe it or not, a Bakelite plant 3 blocks from me, operating full time, and that bugs me a lot. But also several years ago, there was a tooth and nail fight over an incinerator going in the town just south of me. Of course, into the poorer sections, shall I say, the blackest sections. It was like the people that don't matter. We're going to put this incinerator right in the middle of your neighborhood. And people fought like crazy for that. And we were able to get rid of it. And then we were just going to dump everything into our water. And no, you don't get to do that. But I was just so glad to hear about the community coming together and saying, no, this is not okay. You're not doing that to us just because we're poor.
That's really, I mean, it's a serious issue. And unfortunately, the truth is that, there are people like you in every community who are stepping up to, stand up to the systemic oppression and abuse of these communities in particular. So every day, incinerators are unfortunately being placed in communities like that. So, yeah, I mean, it's a it's a good real life example. It just shows you that the stuff is happening.
Thank you. And this was a wonderful presentation. Thank you so much.
Thank you. Thank you.
I remember when that dump in Beverly was a dump. I used to work at the motorcycle dealership, and it would be like your backyard. And it was like, yeah, they're dumping more bulldozers, and you pass it on the highway. And then it got capped. I didn't see the solar cells. I don't see that on the highway, but that's pretty neat. You had gas and solar in the same area.
It's a great example of how that can be sustainable.
There's another one that's somewhere down off of 128 south of Danvers that they had a similar land fill and cap and did some other energy salvage from it. It's not just luckily.
Vivek?
I have a question. Yeah, I think I know the answer to this, but what if all the poorer countries just stopped accepting these ships? I know it's a political issue, but
yeah, so I actually have an answer to that one. The reason why they can't is because American businesses and companies are loading this trash, which is in international waters, technically below a certain grade of trash. It's considered illegal contraband. You're not allowed to ship it. So when it arrives at these ports in other countries, they're opening it up. They're seeing that it's illegal trash, but basically they're not allowed to send it back. They can't refuse it because it's already in their ports. So their hands are tied. I mean, I guess in theory you could illegally ship it back, but that's just a whole new world of problems. And most of the countries just end up dumping it somewhere because it's illegal to do anything else with it.
That's
terrifying. That's horrible.
I don't understand who's paying who to take the trash in the first place to give it to somebody that doesn't want it. I mean,
yeah.
Are they being told we'll build you a facility to get rid of it, and improve how do they wind up doing that one way? It's like we're sending it to you. You have no choice. How does that work?
Well, I mean, the when they send the trash over, it's these companies, typically it's disposal companies that don't want to take the time to actually process the trash, recycle it, potentially sort it, all that stuff. So it's more occasionally, sometimes it's less expensive to just do it here in America, but most of the time it's less expensive to send it overseas to these countries. You put it in a shipping container, and I believe I showed a picture of what those shipping yards look like, but there's not really much regulation on that. No one's poking around in every single container. So it's often just cheaper to put it in one of those and have someone else take it across the ocean. And then it's no longer your problem. So it's these waste disposal companies that are doing it. And often it's illegal.
Wow.
Well,
can I ask another question?
Patty, go ahead.
Thank you. We're seeing a lot of reports of, I'm going to use the word gizmos. They're gathering the trash out of the ocean, thank God, preventing all those animals from eating it. What happens to that once they gather it and get it out of the ocean? Where does it go and what happens to it? Do you know?
I do somewhat. I mean, I talked about how we're handling trash. Hopefully, when it's gathered out, it's not sent out of the country or incinerated. I mean, ideally, it's recycled, it's reused, or it's put in a sustainable landfill. But the truth is, no one really knows. I mean, I'm sure the environmentally conscious people behind these gizmos are ensuring that the trash goes somewhere safe. But the truth is, as we know, it's a dirty industry. Not everyone plays by the rules, so the trash could end up realistically anywhere. It's anyone's guess, but I bet they do take precautions to ensure that it ends up somewhere sustainable.
I hope so. Thank you so much for Hayden.
No problem.
Really great.
Tom, I think you have the last question.
Well, I hope I can make a question out of it. Hayden, you showed a lot of
possible methods to environmentally properly dispose of waste plastic. But I think without exception, they are all more expensive than the non-environmentally sensitive ways, appropriate ways rather. The reason my perception is that there's no incentive, either monetary or regulatory, to do it differently. Regulations are tough, and it's hard to capture all that misuse of the material. But if I could put in a little plug here, I'm involved in a startup that has a method to generate some cash flow for proper disposal of plastics. The concept is you would find those methods of proper disposal and have them generate what's called a plastic elimination certificate. And then you could sell those to the plastic producers, who could then brand their products as being net zero plastic. So I don't know what you think of that concept, but we're trying to do a startup, and we've got some hot leads in Norway for starters.
Interesting. Yeah. I mean, obviously, that's the $1 million question, Same thing goes for these nonprofit organizations and all these people that are trying to do good while the cash flow and the revenue just isn't there, That's, the main issue. And I think that is one way of tackling it. I think that's a really good idea for a startup, being able to market your plastic as being like, you could put like a little stamp on there that says, I will be recycled. Something along those lines. I think that could be a good way to incentivize corporations to be sustainable, since the legislation and the cost effectiveness isn't there initially. Yeah.
So Tom, could you please put your whatever link you might have for that in the chat? And I will stall for time. And oh, there it is. Wow, faster.
I was ready for that.
Could you type just a basic phrase or a sentence of what you just put down? Startup for I don't know how to say it.
Excuse me while I go grab some water. 1 second.
All right. So yeah, in the meantime, here we are, each of us living in our little worlds, trying to do what we think is right, and knowing full well that we can't swallow this beast ourselves, the whole beast. And so here we go. Net zero plastic to provide plastic elimination certificates for producers to brand as net zero. Thank you, Tom. So
well, thank you,
Hayden, Bridget, and Eric, who's probably asleep at this point. I want to thank y'all and to encourage others to support Seaside Sustainability. They do have interns, and I'm sure that requires a certain amount of support to make sure that the interns are properly involved and managed. And I congratulate Bridget and Hayden on what you've done already.
Yeah,
absolutely.
Bridget should receive equal thanks. She's been a major contributor to this project. She's helped me every step of the way. So
yeah,
I thank Bridget a lot for that. She's been a really good mentor and helpful throughout the whole process.
Thanks to both of you.
Hayden, thank you. So I'm going to draw this to a close. I want to thank you all for attending, and may the Schwartz be with us all.
Yep.
Bill, as always, thank you for inviting me.
Have a good night, everyone.
Thank you for having me.
Thank you.
Thank you.